I'm Scott Snyder, Product Marketing Manager at Crank Software, and today I'm speaking with Rodney Dowdall, our lead product architect for Storyboard, our embedded GUI development framework. Today we'll be discussing what can be done to reduce the size of GUI applications to provide a powerful, sophisticated experience on these products. Welcome, Rodney.
Hey, Scott, how's it going?
So while MCU hardware has always been a popular choice for low-end products, as they become more powerful, many embedded projects are now looking to leverage them for all sorts of embedded devices. So how much memory or storage does the Storyboard engine need to run on UIs of this type of platform?
That's a great question, Scott, and it's one that we get a lot. And typically our answer in the past has been to say it depends. And that may have been the wrong answer because I think people feel we're avoiding answering the question when we say it depends. And what we really should have been saying is it's configurable. The Storyboard engine allows you multiple options on how you want to deploy the engine to an MCU target. And using those different options, you can configure your deployment for memory usage or for storage space and drawing directly from Flash. And therefore, or some mixture in between even. And so using that, you can really structure your UI the way you want so that you can leverage what your MCU device provides for you.
Okay, so when you say it's configurable, what exactly does that mean? So like what kind of options do users have to maximize memory or storage usage?
Well, I think it'd be better if I show you. So I'm just going to share my screen here. Just hold on one second. Battle cry of 2021. Can you see my screen?
Yes.
Awesome. So here we have, a typical project that, we'd be working on. It's the smartwatch, storage for the wearable market. And this is the type of thing that will go to an MCU platform. And I just wanted to show you some of the options that you have available when you export. Now, this is our resource export configuration editor. And this is where you can tune how the resources inside of your application are going to be pushed to the MCU device. So when you're running on an MCU device, we use something called the virtual file system. And this file system is like a mock file system that, simulates a real file system. And what happens is all your resources get pushed down as a binary blob. And we use this virtual file system to find where resources would be on the system. And when you use the virtual file system, you have a couple of different options. So for the first one, we have the ability to switch how your fonts are going to be rendered. So for fonts, you can go TTF, which means that the font is going to be read from a file and glyphs are going to be stored in heap or memory. So you can see over here that we're going to use about 512 or 510 kilobytes of heap RAM for the font. But if I switch that to bitmap and I say I'm going to pre-render them, all the memory for the fonts is now gone, but my storage space for the fonts has gone up because we're going to pre-render all those glyphs and store them on Flash and render them directly into the UI from Flash. So now our storage space has gone up. This is the sort of example when I say it's configurable, this is what I mean. You can choose one or the other based on what makes sense for your project. And it's, it basically, there's other options here with the bitmap font too, where you can actually go in and based on a font size, you can even select the glyphs that you want to export and further shrink down the number of glyphs that you're pushing out for that font in the bitmap case. Now that's just for fonts. And we have some other options too, for example, on the images. So in native format, what happens in the native format is we push the image out as a PNG or a JPEG, and those are compressed image formats. That means that the data is compressed down so that the data size for the file is smaller. It's smaller so it doesn't take up as much space. But that means that it has to be uncompressed and pushed somewhere, and we use memory or heap to store that image when it's uncompressed. So we uncompress it into RAM, and we do that because that's a performance benefit. We don't want to have to go to the file system all the time and decompress this image every time we want to draw it. So we decompress it once, store it in memory, and save it there, and that gives us the performance boost of being able to just draw it directly out of memory. Now, if you're on a system that doesn't have a lot of memory, and you have a lot of images in your application, you can see here we're going to use about 16 megabytes of heap space if we were to draw every image that's in this project. Now, there's some tuning that you can do there so that you only have so many per screen loaded. For example, if you look at the resource details, you can kind of see how much each of your screen is going to take up for memory, and you can kind of tune how much memory you want to allow images to go. But there's another way too. You can also say, I want to draw these directly from Flash. And there's some direct draw options that you've got here. So you can say, I want to draw all my images directly from Flash. And if you do that, you can see all the memory just got sucked out. And we don't use any more heap for those images. That's because we're going to draw them directly from the Flash. We can draw quickly from Flash. Now you can see my storage space now is uncompressed images stored on Flash is now 16 megabytes. So if you've got 64 megabytes of Flash, but only a small amount of memory, this is a configuration that makes sense to you. You could use this configuration, and then, you know, that way you're maximizing your memory usage, and you're making use of the strengths of the MCU platform that you've taken, and you know, using that Flash space that you've got to store your images. And there's some other options here too, like, you know, if you have images that don't have any alpha in them, and your display is a 16-bit display, well, why not store the image as 16-bit as well? And you can see we've now even shrunk the size that you're going to need to use on the Flash down by half, because the images are now, you know, shrunk down. And, you know, it's not one size fits all in some cases either, because, you know, you've got these global export options, because these are the ones that we're going to say, hey, you know, I think I want most of my images to be, you know, direct RGB 565, but maybe there's an image in here that has alpha. Maybe, you know, I'm just going to pick one at random. Maybe this button volume arc has alpha in it. Well, I can change that one, and I can say, well, I want it to be direct draw, you know, direct RGB 8888, which is 32-bit. It's got some alpha support. Or maybe, you know, I'm okay. This is a small image, and I want to maximize my storage space, so I'm going to make this one native. And then therefore, you can see up here, I'm now using 11 kilobytes of heap for that one image. So this is what we mean when we say it's configurable. You can structure how you want your resources to be stored on the system so that, you know, you're maximizing your Flash storage capabilities and your memory heap capabilities.
Perfect. Wow. Okay. So with that being said, does Storyboard have any tools that are native to it that can really provide help to developers to uncover the size of their storyboard built GUI applications within the framework?
So that metrics tool that I was showing you is definitely one of the ways that you can see how much is being used inside of your application. We also have performance tooling metrics that when you run the application will output how much memory we're using at certain times. And you can also instrument your Lua code when you write it to show how much Lua is using for memory as you go through. So you can run your application, see how much memory your Lua code's going to use, and then structure it and say, okay, well, is there a way that I can, you know, minimize the amount that Lua is going to use when it's running by maybe dynamically loading in and unloading Lua modules?
Okay, perfect. So before we wrap things up, do you have any additional tips or suggestions that you can provide developers looking to maximize the space on their embedded hardware?
To maximize the space, you know, you want to keep your images a little bit smaller, you know, structure them down. There's a couple more tools that I can show you inside of Designer to help you maximize your tools or maximize your image size. So for example, if we look at here, we'll go to the images view. There's a resource cleanup. So if you click on this tool, it will go through and it will look. And for example, right now, this is not being used by anything in my application. So I can free that up and get rid of it. That's going to optimize your storage space because you're not putting out images that you're not using. So we could do that. The other thing you can do is there's this convert images to fill. And what this will do is it will go through the application and it will check all of your images and it will say, is that image one solid color? Because an image is going to be stored as a block of data, whereas a fill can be rendered dynamically at runtime, not use any memory, and just draw a fill to the screen. So you can convert your images to fills. That will save you space and memory, and you'll get the same look and feel that you want within your UI because it was just going to be a solid color anyway. So that's another tool inside of Designer that you can use that can help you maximize that storage space and memory space. And then finally, the other tool that we have here is the consolidate multiple images into one, which will go through, look for images that are all being drawn within one control and that aren't changing, and then map those into one image. So rather than put out 3 images of all the same size where there's alpha and you know overlap there, we'll combine those all into one image. So you're only putting one image out, and it gives you the same look and feel for your UI.
Perfect. Well, thank you very much for your time today. And thank you everyone for joining us on Inside the GUI.